Today is Wednesday, July 23rd, 2024. So it's a hump day. Yesterday I visited Changwon to meet a big solar installation company, and we had a fruitful meeting. Then today I'm going to stay indoor all day, even though I have customers to take care of. Uh, and currently, I am just lying down on a bench in front of the church called 동명교회. That's the biggest and the richest church in Gwangju, Korea. Yes, I'm pure Korean. I am a KT employee and I work on a domestic side. I wish to have an overseas assignment in different business unit, possibly a sole business group uh, next year. I still have several more years to go before my retirement. As I am engineer in the background, I would like to learn how a semiconductor is made. This article is from Power and Beyond, and the reason I am trying to read this article is to practice English and also pick up some knowledge about the subject matter. Yes, since I am not a native English speaker, I need to constantly focusing on studying English or memorizing expressions on a daily basis, and this effort is part of that idea. So let's get down to the business. Part 1: Semiconductor Manufacturing. Introduction to Semiconductor Manufacturing. This article was written on September 13th, 2023 from Venus Corley. 4-minute read. It will be like a 14-minute read, 3 times more, because I am not a native speaker and I am trying to read it at a relatively okay speed so that I could pick up new words, expressions on the spot right there. Semiconductor manufacturing is a critical industrial process that leads to mankind's easy tech-based lifestyle through consumer electronics, appliances, electrical vehicles, IoT, and many more applications. This 5-part article series details the process of semiconductor manufacturing straightway from the books to the one inside the phone in your pocket. Straight away from the pockets to the one inside the phone in your pocket. This article discusses the basics of semiconductor manufacturing and some statistics. This article explains semiconductor manufacturing in 7 steps. Source: Maxim Shumeljov, stock, adobe.com. That's a stock photo. Industry overview of semiconductor manufacturing. The semiconductor manufacturing industry stands at a valuation of USD 580.1 billion as of 2022 and is expected to reach 1,883.7 billion US dollars in the upcoming 10 years. Wow, 3 times more. The capability of a country to produce semiconductors is a way to estimate its manufacturing sector. So far, only 10 countries are manufacturing semiconductors that empower the entire world. Major semiconductor companies are expanding their operations even more in the top production countries. Malaysia, Israel, and the Netherlands have the lowest numbers but a huge potential for semiconductor manufacturing. Moreover, companies like Foxconn and Intel plan to expand their operations in newer countries like India, Vietnam, etc. The image shows the biggest chip manufacturing countries. Yes, South Korea. My country is included. So let's see, semiconductor manufacturing countries: Taiwan, South Korea, Japan, China, United States of America, Germany, United Kingdom, Malaysia, the Netherlands, Israel, the Soviet Union, Russia. Semiconductor manufacturing process. The process of producing semiconductor devices from wafers is called semiconductor manufacturing. Semiconductor manufacturing is often termed as semiconductor fabrication. Semiconductor fabrication. Semiconductor microfabrication is another process that enables the production of extremely small semiconductors at microscopic and nanoscale levels. The ultimate goal of semiconductor manufacturing is to produce highly reliable, low cost, and high quality conducting devices or chips. Experts divide semiconductor manufacturing processes into 6, 7, 8, 10, or 12 steps. However, similar processes add up to a broader category. A manufacturing unit, referred to as a foundry, is the place where semiconductors are produced. Experts divide the semiconductor manufacturing processes into 6, 7, 8, 10, or 12 steps. However, similar processes add up to a broader category. A manufacturing unit, referred to as a foundry, is the place where semiconductors are produced. It must be noted that not all foundries do follow the listed steps rigidly in the sequence. Foundry. Each company may have its own procedures and regulators. In Korea, foundry has a different meaning in the semiconductor industry, and I think that is kind of Konglish now, right? Foundry is the place, not a business concept. Step 1: wafer manufacturing. The first step in semiconductor manufacturing is to produce wafers. A semiconductor wafer is made from semiconducting materials such as silicon, silicon carbide, gallium arsenide, etc. The impure material is melted to form a high purity liquid that is crystallized through processes such as Churalsk and various others. The cylindrical shaped ingot is sent for slicing, polishing, and further procedures. Slicing, polishing, and further procedures. Cylindrical shaped ingot, cylindrical ingot, or cylindrical shaped ingot, cylindrical shaped ingot. Step 2: oxidization. The process of oxidization develops an oxide layer that provides insulation inside the semiconductor devices. The insulating layer of oxide protects the wafer and prevents unwanted connections inside the device. Such insulation is required to define the junction area and isolate the gate terminal in FETs. Two methods include dry and wet oxidation to form an oxidized thin layer. So there is a dry oxidation and wet oxidation. right? Two opposite processes that produce the same effect. Step 3, photolithography. A photoresist is a UV light sensitive material that is coated over the wafer, so over the oxidized layer, I think. Depending upon the manufacturing process, positive and negative photoresist can be used. A desired patterned mask, a circuit designed through an EDA tool, is placed over the wafer as it is exposed to UV light. In simple words, photolithography is the process of placing thin film circuits on the semiconductor to define precise patterns or circuits. A photoresist is a UV light sensitive material that is coated over the wafer. Depending upon the manufacturing process, positive and negative photoresist can be used. A desired patterned mask or circuit designed through an EDA tool is placed over the wafer as it is exposed to UV light. In simple words, photolithography is the process of placing thin film circuits on the semiconductor to define precise patterns. Photolithography. Step 4, etching. After the photographic stage, the etching process removes the unwanted material from the wafer. Etching. The etching process ensures the correct geometry of the circuit pattern for the semiconductor. The wafer undergoes the etching process many times, while the desired part is protected through a mask. So mask protects the desired pattern. Two types of etching processes are used in the industry: dry etching and wet etching. So once again, two completely different opposite processes: dry etching and wet etching. Wow, it's very cool. I have a very cool wind early in the morning right now. Step 5, doping. The doping process involves adding pentavalent or trivalent impurities to enhance the conductivity of the semiconductor device. A common doping method used in the semiconductor manufacturing process is ion implantation. Impurities are accelerated and ions are introduced in the wafer during the process. Post-ion implantation process, the wafer goes through the process of annealing to check the quality of dopants and repair any possible structural damage at the crystal level. So wafer implantation, right? And the ion is added, and it is called doping. The doping process involves adding pentavalent or trivalent impurities to enhance the conductivity of the semiconductor device. To increase conductivity, use impurities. A common doping method used in the semiconductor manufacturing process is ion implantation. Very popular, right? Common. Ion implantation is called doping. Ion implantation is one of the doping methods. Impurities are accelerated and ions are introduced. That's good expression. Ions are introduced in the wafer during the process. Post-ion implantation process, the wafer goes through the process of annealing to check the quality of dopants and repair any possible structural damage at the crystal level. So doping, then annealing, right? Doping and annealing. In the doping, dopants are used. The common dopant is iron. So impurities are accelerated and ions are added in the doping process. Then annealing is used to handle the structural damage. The dopants are used to increase conductivity. Step 6. Metallization. The process of metallization in semiconductor manufacturing allows electricity to flow inside the device. Various components like transistors, resistors, capacitors, etc. are connected for the semiconductor to function as predicted. In simple words, metallization is the metal wiring to make interconnects and ohmic contacts in the semiconductor. Interconnects and ohmic contacts. Thin films are engineered inside the small semiconductor to provide a path for the current to flow. So metallization comes the next, right? I thought doping, annealing, and masking, they also make the connects, but that's not the case, man. That's not the case. Something fell from my pocket, and I wonder what it is. Nope, it didn't fall from my pocket. I wonder what that was. So that was the metallization. Step 7, quality control and packaging. The electrical die sorting EDS process performs quality checks and tests the manufactured semiconductor for reliability. The process is a final check to eliminate faults inside the wafer. Packaging semiconductors is the last step of the manufacturing process. Semiconductors are cut from the wafers separately and are put in different shapes and packages. The foundry sends the packaged device to the selling unit, finally reaching the consumers. Quality control and packaging. Electrical die sorting is called EDS process. Electrical die sorting, right? Electrical die sorting, EDS, performs quality checks and tests the manufactured semiconductor for reliability. Subscribe to the newsletter now. Don't miss out on our best content. Subscribe. Semiconductor manufacturing's article series, semiconductor wafers, semiconductor circuit design, key chemical procedures, doping, the semiconductor character, microfabrication testing, electrical die sorting. So they have a place on LinkedIn too. Basically, there are 7 steps. 1 is wafer manufacturing. Cylindrical ingot is produced after meshing and liquidifying the silicons or silicon oxide or gallium oxide, and that big chunk of silicon cylindrical shaped wafer is sent to the foundry. Foundry is the place where the semiconductors are made, and from there they first cut the ingot into slices and polish them, and they coat the wafer, a wafer with oxidation. Oxygen, a layer of oxygen helps to separate the wafers from any device or impurities first. It's like a protection layer. It's like a condom, right? Then step 3, photolithography. A film of circuit is placed over the wafer, and it goes through a UV light treatment. So it's kind of masking and parts just under the mask is protected from the UV light, and it stays right there, forming a desired circuit pattern. Then etching is used. Etching means there's wet and dry etching. If you pour some liquid over the wafer, which still contains the photolithographic mask, then the other parts of the wafer are washed away. It is called etching, right? And step 5, doping. Impurities are accelerated, and iron is added to increase conductivity. So they are called dopants, right? Doping. From here, I decided to memorize some expression, right? Impurities are accelerated and ions are introduced in the wafer during the process. Then metallization. Metallization is basically adding interconnects and ohmic resistors. Basically, they are produced to make connections between transistors, all the resistors, FETs, like a field effect transistors, right? Field effect transistors. Step 7, quality control and packaging. Electrical die sorting, or EDS, is used to finally check the manufactured process to sort out any defects. It's called EDS tests, right? Then all the OK wafers are sent to sales, reaching the customers in the final process. And there you have it. And once again, the place where the semiconductors are made is called a foundry, right? It's not a business concept. That's the way it is used in Korea, but I need to further research into that concept later to see if it's a Konglish or a misnomer, or if that is true, right? Foundry is a business concept where in Korea, foundry is called like a foundry business is said to mean that like a Samsung Electronics, the foundry produces chips for other companies like OEM process, but that's not the case. So that was the basic synopsis of this article, and this article was from powerandbeyond.com, and the author was Venus Carly. It was a good material to read because I have engineering in the background, right? Have a wonderful hump day wherever you are.